the actors, the stakeholders that are participating to the platform, and that they are able to store or to upload their data into the platform. There is of course a layer for data gathering. Then there is the core of the big data platform itself. Within the platform, internally, it is organized in different bundles. Each bundle, of course, is dedicated to one specific activity or task. But what is worth to mention here is that, well, basically, if I want to upload my data, I can share my data with other stakeholders by signing a smart contract. Okay. Well, if I want to upload or to develop my own service, I can use a specific bundle within the platform and give access to my application to a simple data owner that want to upload their data within the platform. So advantages are basically twofold: for the data owner to share the data, and for the service developer, service provider, to provide these services to data owners. Through this platform, we are able, of course, to create added values in the business, new business opportunities. So the main innovation and value proposition you can see here, of course, the an holistic data platform enabled to provide this kind of secure end-to-end data transfer or data managing, and it constitutes, of course, one unique one-stop shop for all energy stakeholders. So who wants to buy data, who want to sell data, but also who want to buy or sell analytics, okay, services. Main achievements we've got so far. So we are now, as I said before, in the last 6 months of the project, we have issued 2 releases, well, beta release in the first half of the project and 2 more release of the platform. We have developed on the top of the platform 12 applications and 5 more applications funded by an open call. So we have basically a portfolio of 17 applications running right now. We have stored in our platform more than almost 400 datasets from different stakeholders. Of course, this dataset comes from the pilot sites, but not only, also from external data services. We have 34 pre-trained analytics that are basically the calculation engine of the services of the application that are running on the top layer of the platform. We have 55 KPIs to monitoring the performance of the platform and the services. Almost 300 analytic results. We have signed approximately 200 smart contracts to allow data owners to exchange their data with service providers, or also to data owner to have access to analytics. And 21 demo case and 17 business models. So the applications, as I said before, there are 17 in total. 12 have been developed by consortium partner. 5 more have been developed by externals to an open call. The 12 developed within Synergy, you can see here, are organized in 3 main blocks. The first block of applications on the top is for system operator and REST owners. So all the aspect dealing with the grid, power system, kind of grid flex, something like this. The second block of application is dedicated, is aimed to retailers and aggregators. While the last one is for facility and facility manager, but also urban manager. So here you can see there are two more that I somehow highlighted. One of these applications is also covering some flexibility aspects. So I'm going to present now some functionalities of this one here, retailer and aggregators portfolio analytics. Well, this application is, I would say it's kind of in the middle between Serviflex and Marketflex. It basically offers some tools and functionalities to retailers and market operators to enable to facilitate the adoption of flexibility or the flexible capacity of their portfolio, of course, for market or grid aspects. So it exploits all data available to analyze in detail the composition of their portfolio. It is helpful to have insights of the portfolio as a whole, of the aggregators or maybe of the retailer, and it offers some other services to minimize the deviation between the demand and the generation, and optimize the target user transaction using accurate demand and generation forecast models. You can see here the high-level architecture of this tool, of this application. On the bottom, on the box on the bottom, there are, of course, the connection point with the Synergy platform, where all the actors involved are able to upload or download their data. Then we have the core of the platform itself, of the tool, sorry, itself. Here there are two blocks that have horizontal functionality: a forecast engine, that is able to predict the generation and consumption profile in short term, but even in long term, and a customer segmentation module. Then there are three additional modules that are fed by these two modules here. The first one called wholesale market participation DSS. The second one is a market positioning optimization tool, and the third one is a PPA optimization tool. Well, the segmentation, I will skip the forecast because it is a simple deep learning algorithm that is able to predict 1 day ahead, or even in long term, years ahead, the generation of the consumption. The segmentation model. Well, this tool allows aggregators and retailers to basically to cluster their portfolio according to three different categories of segmentation. One for elasticity, the other one for socioeconomic, and the third one for temporal distribution. For elasticity, basically, we are able to organize, to identify the different patterns in our portfolio across different categories of elasticity. We can set price elasticity, so we want to understand how fast the customers react when the electricity of the price changes. So in a dynamic price scenario, it is helpful to understand how the capacity or flexibility of the customer when the hourly price maybe is changing. Also, we can have elasticity in terms of the speed of load of profiling change, so kind of a detection of a ramp up or down. The second one is socioeconomic segmentation, so we can organize our clusters, our portfolio according different categories of users. So whether they are retired or maybe they're working, young, old, geographic position within their the grid where they are connected, and also the tariff that they, of course, they have in their the energy provision. And third one is the temporal distribution of the clusters. That is basically how in the day they use to consume the hourly consumption profile in the different hours of the day. So forecast and clustering are useful for the wholesale market participation. In this case, we are able to understand the deviation of what is being forecasted to what is actually demanded or generated by our portfolio itself. It is useful, of course, to understand if the retailers have to adjust their participation in intraday market and reducing the imbalance. The other functionality is called the generation allocation. It basically when it is able to allocate all the generation capacity from the portfolio to the demand profile of the portfolio according to the clusters identified in the previous steps. So through the different profiles of generation, aggregated generation, how the aggregator of the retailer is able to cover its own demand. And the third one is a PPA optimization. In this case, well, you know that when you're facing with the PPA, we're talking most of cases with brand new assets. So you don't have historical records of your PV plant or wind plant. In this case, we're talking about PPA for a PV plant. And this functionality is able to predict the generation of the considered PV plant, or also an aggregation of PV resources up to 15 years ahead, forecasting all the electricity price in the market, well, the production, of course, but also the cost, degradation of the plants, and also the cost for the O&M. And then it can give you the optimal price to close the PPA. So in terms of euro per megawatt hours. Don't worry, Lola, the final slide. I will skip this kind of recovery slides. So it is only one tool that we have in our portfolio of application. As I said before, it is useful for aggregators and retailers to enable exploiting the flexibility capacity they have in their portfolio. Also, through the Synergy platform, some advantages that I have tried to recap here in this last slide. Of course, the platform itself, with all its information, its data communication protocols adopted, it's totally interoperable also with legacy devices. It offers a unique marketplace to exchange, in this case, data and services. We're not talking about pure electricity or flexibility market as in Marketflex. It is fully compliant with all principles for data privacy, data security, and in general, data sovereignty. Data owner has the full control of his data. Platform manager and platform owner neither can see the data uploaded by the data owner unless they sign a smart contract with him. Smart contracts can be totally customizable according to what the data owner want to write in that. And of course, it offers a lot of possibility and opportunity in terms of businesses, because of course enabling this common data sharing and common intelligence over the data, that it is possible to be shared across the stakeholders. So this is my last slide. Thank you, Lola. Thank you all.
Thank you very much. Now it's time for Ibarra's groups with Noemi Jimenez for the motion.
So good morning, my name is Noemi Jimenez. I work for FEMOSA, which is the coordinator of the Ibaran Plus project. And the project is in fact coordinated by my colleague Jacobo Peralta, but he's in Munich today in a Smarter Europe conference. So I am the director of the Research and Innovation Department, and I'm presenting this. I hope I can do well. Okay, so this is the content of my presentation. I will present an overview of the project, the challenges we're facing, the project solution, and finally the conclusions. So in here you can see, well, Ibaran Plus is another Horizon 2020 project. We are 15 partners in 10 countries. We have for the Mosaic Plus a virtual lab. We work on 7 core technologies, and the project duration is 4 years. We are going to finish in January next year, and the year funding is 8 million euros. In here you can see the consortium, so I'll go fast with this. Well, the goal of the e-balance project is to develop an energy balancing platform to increase the flexibility and the resilience of the electrical network. In here you can see the context of the e-balance plus. So to the left you can see the classical power plants. We don't deal with that. The transmission system, we don't deal with that. And here you can see surrounded by the yellow marking what we deal with. And so we take into account the medium voltage, low voltage, and so we take into account the station, distributed energy generation at different levels and loads. And in particular, we put a lot of focus on buildings, since buildings, the integration of buildings in the energy flexibility market is quite useful, because buildings are responsible of a high consumption. Here you can see the challenges that we face when dealing with energy flexibility. Energy flexibility is not a mature concept yet, and so these are the challenges that we are facing. Firstly, they are not standard regarding how we measure and how we define the flexibility, or how we estimate the cost. Secondly, the energy flexibility is a difficult dynamic concept because it varies with time and decision taking, and also is subject to a great deal of uncertainties in forecasts of energy consumption, generation, prices, weather, etc. And finally, we need to manage a lot of technologies with different communication protocol, data formats, so interoperability is also an issue here. We are trying to provide solutions that can somehow tackle these challenges. So firstly, we are proposing a data exchange format for flexibility. Secondly, we are developing a method that every 15 minutes we do forecasting for the following 24 hours ahead, and then we have provided a needed solution to deal with interoperability. So this is the solution that we proposed. We propose an energy balancing ICT platform to provide flexibility and resilience of the electrical network. The main feature of our eBalance platform is that it follows the topology of the electrical network. And so in that regard, you can see here the topology of the electrical network. We have the low voltage level with the different customers, and we may have also distributed energy generation. We have the medium voltage levels that gets information upwards, and then finally the transmission system. We are really with the transmission system, so we stay around these two levels. And our system is based on the definition of what we call management units. We have one management unit in each of these nodes, and all these management units work mostly the same. Each management unit control the loads that are linked to it, and do and run the energy balancing and flexibility algorithms, and publish upwards to the parent unit the result of that balancing. The management unit at each levels also receive command from the parent unit. So the parent unit may be asking for some flexibility, and so this management unit here solves the algorithms to provide the flexibility requested. And so, as I said, all the management unit, this is a fractal lie architecture, and that means that the different management units that we deploy at the different levels mostly work the same. So as each level, we have a management unit that manages what is connected to it and report upwards, then this management unit manage what is connected to it and report upwards, and so on. And as I said, the management units are mostly the same, and the algorithms are similar. And also I wanted to emphasize that in here, of course, we need to deal with cybersecurity issues, but also we have a distributed system, and so we have different databases in the different small pieces, which are the management units. That's also an advantage of the system. And I started mentioning that it is difficult to define the flexibility concept, and so for our project, we have defined time step of 15 minutes, and we have done so because that the time step usually used in most countries for billing. And at each time step, we make prediction for the 24 hours ahead in 15 minutes period, so that means we do prediction for 96 periods. And so at each time step, we predict the energy demands. This is done in the management unit. The management unit predicts the energy demands of the loads connected to it, and also the flexibility that the different loads can provide flexibility up or down. It means flexibility down means that the prosumer may reduce the power, and up that the prosumer may increase the power. Also linked to this prediction, we also estimate the cost of such flexibility. We also offer the prosumer may decide if he wants to provide the flexibility as a whole block, or if it can provide it allows the system to modulate the power offer as flexibility. And so the core of the eBalance Plus platform is the development of the running of these energy balancing and flexibility algorithms. As I say, they are based on the data format which I have explained. It optimizes the energy cost for 24 hours ahead based on forecast and also on the commands received. It also estimates the available flexibility for 24 hours ahead, and at each level, the management unit publishes upwards to the parent unit, and also the management unit can activate the flexibility requested to the load connected to it. And the process is repeated every 15 minutes. So because we do the prediction every 15 minutes, we reduce somehow the uncertainty, because we very frequently we are reacting. Well, when we started the project, firstly, we defined the different use cases that we needed to analyze. And so we defined 11 use cases, and 4 of them are related to these energy balancing algorithms, which I am detailing here. And so I will go through them. We define these use cases using the standard that you can see on the slide and that can be found in Bridge. So the first use case is the baseline of all use cases, and this is the use case that define the hierarchical structure of our architecture. So this is the use case that define how we manage the different units and how the connection is always upwards among the different units. The second use case is related to the interoperability solution to integrate buildings in energy and flexibility market. So the goal here is to develop the middleware solution to coordinate the different technologies at building level, HVAC system, renewables, monitoring system, and the different communication protocols, etc. And also allow the integration of buildings in the energy market. So this use case has been tested in 3 of the demo sites that we have, 3 of the 4. And the first one is the University of Malaga, where we have a demo site, which is a smart campus. And in here, we have been deploying 21 devices in 4 buildings, including monitoring system, PV, HVAC monitoring system, batteries, vehicle-to-grid charging points, etc. We also have another demo in the University of Calabria. In this case, it includes buildings of the university, offices and labs, but it also includes residential buildings. And so here we have integrated 69 devices in 6 buildings, including electric monitoring, PV monitoring, residential building, smart appliances. We also have a DC nanogrid and smart batteries, etc. And then we also have deployed in the University of Lille, where we have 3 buildings with all the system again that you can see there: smart metering, PV monitoring and control, electric boiler, smart batteries, electric vehicle charging point, etc. The following use case is about the integration of energy system, some energy system at district level. In particular, this is about the integration of electric vehicle, vehicle-to-grid, charging point, and PV generation, and smart storage. So what we do here, we control all these devices, the vehicle-to-grid, the PV generation, and the smart storage, so that these behave as a virtual power plant that Diego and Lola were mentioning before. And so this use case, as I said, for the managing of the DC grid station, supplied by PV panels and also by batteries and connected to the grid. For this, we have developed a mobile application in which the user defines at what time he's going to pick up the car and what is the percentage of the battery that he wants to have load. And so the application also offers the possibility to select between direct charge, which is charge the vehicle right now and finish whenever you finish. The second one is with a flexible mode. It means that the system will decide when it is the best timing for charging the vehicle according to prices, so that it is cheaper for the user. And the more sophisticated mode is the bidirectional mode that allows the system to use the vehicle as a battery, and so the system will be allowing to load the vehicle or to supply to the grid, and again the system will use the most convenient time to do so, so that when the user arrives to pick the car, he has the requested energy in the battery. And then this is another use case, which is the integration of buildings in the energy and flexibility market. Again, this is the definition of a virtual power plant. The building is as a virtual power plant connected to the energy and flexibility market. And so Here, the use case developed the algorithm for the optimal management of the energy system of the building, and also for the estimation of the flexibility that the building can provide. As I said, this is done at distant state for 24 hours ahead regarding the energy prediction and also the flexibility prediction. We have applied this in 3 of the pilots that we have. We have residential building and also other buildings such as university. And so for the residential building, we have also developed a mobile application where the user can decide when is his condition of his requirement regarding the functioning of the dishwasher or whatever the smart appliance. And so I have explained the performance of the energy balance plus platform, and then this solution that we provide can be useful both for aggregators and for DSO. And so in order for aggregator, for example, to make use of this technology that we are developing, we have developed an API and a service in the cloud, so that the aggregator, by means of the API and the platform provide on the cloud, can access to the platform that we have deployed in the different management units. And so in here you can see if the aggregator needs flexibility, it goes to the API and to the platform. The platform identifies which customers are related to this aggregator, send the information to the different management unit in the grid. We do the computation, and then the aggregator receives the option for flexibility and the price. And similarly, this methodology that we have deployed is also useful for the BSO, may be useful for the BSO in case the BSO has congestion, that it can to solve the congestion, the BSO may request for some flexibility. And so again, by means of an API and a service deployed in the cloud, the BSO may ask for flexibility whenever there is some congestion. And so, as a conclusion, the work done, well, you can see there a summary. So we've been working on the middleware solution to integrate the different technologies in order to participate in the electricity and flexibility market. And we have been deploying in 13 buildings, providing flexibility services in Spain, Italy, and France. We also have developed the energy balancing and flexibility management algorithms to optimize energy costs and estimate the flexibility profile and the cost for that. And we also have been working on data exchange format to support market mechanisms and flexibility aggregation. Just a second. So the final step, the project is finishing in January. We are mostly finishing all the technical development, and we plan to start. We have been measuring in different places and different. I mean, we have done some measurement and some demo for the moment, but the real demo will start in September 2023, and we will be finishing in January. So we will be compiling data. We will be mostly taking data until December, and then we will be doing reports and everything. We are working on the business and exploitation plans. We need to be working on the evaluation as Laura did for Flex, which is more advanced. And we would like to see you in Paris in that event. And this is it. Well, this is it.
Thank you very much.
Okay.
Very good time. And to finalize, just with this flow project.
I think Session ends at 12:30, right?
Sorry?
That session ends at 12:30 or what?
It's the last one.
Yeah, but how much time?
And
So
so,
we did.
so the
Oh, it's
exhibition
one.
at
Okay.
Yes, because they extended because it's, we were 3 projects and they asked me to do also flow and I forgot time.
Okay.
So yeah, we have the official inter one. You can take
I can do the
Two
5-minute version or the 20.
20.
the official one is 20.
Okay, perfect. Okay, so thanks for joining, and so I'll be talking about flexibility from the EV place. Nomi had mentioned the use case 8, so that's essentially what this project focuses on. Flow. So I think the general ideas session was talking about flexibility, and again we'll focus on the vehicles for this flow project. So my name is Josh Eichmann. I'm at the Catalonia Institute for Energy Research in Barcelona, and we're leading the project. We're coordinators for the project. And just a brief background, I think in general, Flow looks at enabling and valorizing flexibility from the mobility space. So I think it fits really well with these other projects and ends up being a subset kind of, because we're focused essentially on the vehicle plate, on the vehicle space. And then we know there's a lot of policies and different laws and regulations that are coming out with respect to how vehicles are going to look in the future, how the mobility space is going to look. So there's a large focus on converting from combustion engines to electric vehicles. And so this project works on the scalability of some of these flexibility solutions to support DSOs, TSOs, users, and then also meet some of those requirements by enabling easier, more rapid, more effective transition to electric vehicles. And in the end, we recognize that there's some of those grid challenges that we'll be able to address, decarbonization and enhancing the existing renewables. So as far as the project, there's 30 partners, and like all the others across the entire value chain. So in the end, hoping to be able to demonstrate this. We have 5 demonstration sites, or pilot sites that I'll talk about a little bit later. So I think one of the easiest ways to see kind of the breadth of the project is to look at where our innovation pillars are. So this is generally what we're going to focus on, and then I'll provide a few specific examples of the things that we're doing. And each of those will relate to kind of activities that will be eventually released in deliverable reports or actual pieces of demonstration, so that everyone here can access them if they want. So, but first, kind of stepping back, in general, the project has these kind of 7 areas where we focus on, which is the first is kind of user-centric design, user-centric application. So we really understand what our users' needs are, then we develop it and implement it and look at their experience. So that is a really key piece. We've heard interoperability before. I don't think there's any argument here about the importance of interoperability. So that is one of the foundations for the project as well. And in general, in the EV space, we've done this classical immediate charging where you plug in the vehicle, and then there's delayed charging where you just try to get to some time of use, low cost utility rate by delaying. But I think where we look at this in the future is we see this evolution where every charger is eventually going to have these smart capabilities. So that is kind of the foundation of the project, is that we're anticipating that that's going to be the status quo, the kind of business as usual, that every charger will have that, and we can work in that kind of environment. And then next, we're developing a number of different tools, and again, that relates really well to this session, and tools in general at the higher level, looking at planning and assessment, so understanding how many vehicles we anticipate in the country or in a region or on your street, and then understanding the impacts of those to both at a general level, like how many vehicles are there, what's the CO2 reduction as a result of these, or the amount of fossil fuels that are offset, but then also looking at the distribution system and understanding impacts on the distribution system level. And then next, I kind of link 4 and 5 together because we're looking at actually integrating these systems and then getting the best operation out of them. So it's a combination of forecasting, optimization, and then demonstrating that through our demo site. And then finally, the scalability piece. Again, that was a big request in the call, and then so we've translated to the project. And through the use of these demos, we're looking to show that these things that we've talked about before, smart charging, and in both the the typical unidirectional charging and bidirectional charging, that these are solutions that can scale and be repeated to many different sites. So we have 3 demos and 2 test beds, and hope to demonstrate that across all those sites. Again, I'll talk about those in a moment. So to give a sense for kind of the activities that we're actually engaging in, so you can say, oh, if I'm interested in this, there already is or eventually will be a report available there. We're in year 1 of the project out of 4. So for these, I'll tell you what is available in case there's interest and what will be available soon. So the first item where we started is kind of the state of the art, what are the current stakeholders, and again, in this kind of, when you're looking at these systems and the mobility sector, there's a lot of different partners, a lot of different parties and stakeholders. So first understand that, and then what are the kind of existing policies and frameworks that we're working in. Next, then we move to developing baselines, how many vehicles are we expecting, and develop some scenarios there. And then look at the potential barriers that exist in these cases. So, through the project development process, we recognize a few now, understanding, a year later, or now that we're doing this project, how that's evolved, and see what the real barriers are now. And then I mentioned that some of this will be available. The reports in those areas are publicly available. We have 3 different reports that address one for each of those items, so you can go access those on the website if there's interest. Kind of, again, set the state of the art, the literature review for this kind of space. And then when we're looking at user engagement, though, that's kind of our next activity. It spans the entire timeline of the project. So we've done some user engagement activities, and that's all that's available. But eventually, all those other reports will be available, so you'll be able to understand what their needs were and requests and challenges. But as I mentioned, we kind of are going through this process where we first identify users, some that have electric vehicles, some that don't, or that want to, some that don't want to. We try to get a nice cross-section of everyone. And then ask them what their needs are, what they would look for. We involve that in the prototyping process, and then we're demonstrating it in our demos. And we're getting feedback from them on, is this what they expected? Does this work? What's the level of acceptance as a result of that? So the idea is to kind of holistically integrate the users into this project. I mentioned the importance of interoperability. It obviously spans a variety of different topics, including some of at the basic level, a communication protocol could be what are the specifications for a charger, or how should these 2 devices communicate? And then we're looking at that, again, in detail, but kind of zooming out to understand how can all of these things work together, where are the missing pieces, and where do we have to contribute? Because there are a lot of activities going on. There was, protocols that are just released that are now being integrated into the infrastructure. So we're in this weird place, I think, in the vehicle space where there's some really important, really impactful protocols that need to be implemented. So there's a lot of infrastructure that doesn't have it, won't have it, and we need to kind of get to the new infrastructure. So that, for this project, in this moment, I think is a really important time for it. And then we're also working on the data privacy and cybersecurity aspects of that. So given all those, and given our interest in integrating it, how do you protect those from any threats? And I think in this moment, that part of the project is going to be, I think, into the 2nd year, but half of the deliverables are going to be released within the next few months. So if there's specific interest in those, again, you can check the website to see those in a few months, and they'll be released. And then the other kind of half of them will be released in the year or so. And then I think the biggest piece, and particularly for this panel, the one that I wanted to focus on was some of the tools, digital tools, and it includes some things that are more in the software space, some that are in the integration space, and some in the hardware space. So I just wanted to single out one interesting kind of innovative idea that we're looking at, which is this idea of kind of a modular charging station or modular energy system, where it relies on a common DC bus to be able to add these kind of blocks. So maybe you have at your building, you have PV, you have a battery, and you want vehicles. You can just drop in some of these blocks to enable vehicle charging, and you can shift the power around between them. So I think the idea is that will, in the end, lower the cost and increase the ease of installing and accessing and running this equipment. So that's one of the hardware solutions. And now if I talk about some of the kind of some on more software and some of the integration aspects. So as part of the project and the tools, we're working on largely open tools. Some will be proprietary, but the goal is to get a lot of open tools in the forecasting space, so to understand more details about what's your vehicle demand, what's the charging demand, the charger occupancy, how many of your charging parking spots are occupied, how many of your charging plugs are occupied. So there's a lot of activity there. There has been a lot in the past, and we're contributing to that, maybe incrementally, but contributing to that in different areas. Also, I mentioned in the optimization space, there's a lot of activity that we have going on that is, again, kind of, we're focusing down on specific needs. So we recognize the need to include battery degradation. All the users were saying that if I charge my vehicle or provide this bidirectional capability, so I not only take electricity, but I can provide it back to the grid or a building or another car or something, I'm concerned about how that affects my vehicle. And again, there have been activities in this before, but we're looking at creating these tools that could be scalable and open that others can use, and then we can start and hopefully start and see that expand. So that's one example. Also, there's a lot of interest in this kind of local vehicle routing and clustering. So if we get this kind of ubiquitous charging, a vehicle can maybe autonomously, there's a system that automatically decides, like, this is the best charger for you. And it can go there to support the DSO. It can support maybe your needs if you have low cost or you have a shorter walk or you know some time frame that you're going to be there. So with similar information as Nomi presented in use case 8, maybe a little bit more information is required about the vehicle itself, but we want to look at this kind of clustering and rerouting the vehicles as being one kind of innovative areas. And I think probably the most innovative area that we're working on is this orchestration platform. This gets back to the interoperability. There's a lot of stakeholders in this space, and in order to meet many of their needs and simultaneously meet their needs, the idea is that we create this orchestration platform. So there's a crowd balancing platform you might have heard of from Equity, their Equity platform. So we have them as a partner on the project, and but that deals with largely the TSO needs, right? So there's another maybe a local energy market that would deal with DSO needs and be able to work with the users. But in the vehicle space, we wanted to create a place where we could kind of coordinate some of these activities. So the idea being, maybe the TSO and DSO could both provide their needs. They could do some coordination, and then at the aggregator level, if they had a way to easily onboard customers, they can lower the cost, improve the performance by including some of the optimization tools that we have. And then OEMs also, they can make better decisions about the types of vehicles and size and the software and protocols that are implemented on those vehicles with this platform. So that I think is kind of the core contribution that we're looking at for this project, which essentially involves integrating a lot of the different aspects that we've talked about and a lot of the different stakeholders. So that's why we kind of needed them for the project, and this is how it will be represented. Then I'll also mention, again, skip to the scenario and impact assessment. So that's another open tool that we want to develop. There's a number of them, maybe from the Commission or from the JRC, that have looked at a high level, here's the impacts that we anticipate. But to be able to do this scenario development yourself, so that at a local site, you can anticipate how many vehicles might be there, or regional, across the region. And it'll make a little more sense when we talk about the demos, but then you'll be able to do that, and then also the impact side. So the idea is that those will be tools that are released. I'm not sure the extent to which the orchestration platform will be released openly, but for sure the forecasting, optimization, and the kind of assessment and impact tools we want to release to the community. And I'll end here with the description of kind of the pilot sites, in terms of the scalability where we're focused on. So again, 5 pilots, 3 demos, and 2 test beds. So first demos in Menorca, and have I know one of the other projects mentioned they were looking at a location that had seasonality issues. So this is from tourism. It'll be higher demand in the summer, and then they also, because it's an island, they also have additional constraints there. But if you have the DSO, there is no TSO, so you have kind of access to the entire island in that way. So it makes this a unique use case for it. And all these applications are looking at providing both uni and bidirectional charging, and the services that go along with that. And then lastly, from Menorca, it's a tourist area, so there's a lot of rental vehicles, which creates an interesting opportunity to provide that charging while the vehicles are sitting in case it's low demand. And B2G and off season, so yeah, you can kind of see there's a lot of opportunity, and we'll see what we can capture from all of it. Second is a Rome demo. So this one is going to be it's a larger area. They anticipate a significant growth in both infrastructure and vehicles. So this gives us an opportunity to really test out that scalability theory and the replicability theory in their different regions. And then in Denmark, we took a different approach. We have kind of a distribution of smaller sites, with the goal being to look at kind of different archetypes. So it'll be public charging and private charging and semi-public charging. It'll be urban and rural sites, and they already have a lot of infrastructure installed. And so then it creates a nice demo for us to just come in and apply our platforms, apply our tools to their existing resources. And then we have 2 test beds where we're going to look at demonstrating some of that new technology. One is in Dublin. They have 2 parking structures. Again, they already have charging. They're installing more, so we'll be able to demonstrate some of the tools there. And then in Prague, they're developing a test bed there. They're calling building as a service. But the idea is that there we could actually test that common DC bus system that I had mentioned before. That's kind of an innovative hardware solution. It'll be tested in that location. And their idea is that, it's not just the vehicles. So a lot of what I've talked about is at a charge point, single charge station, but they're also looking at integrating it with PV and storage. So it looks a lot like the other projects that you saw today. So they want to kind of dip their toe into that one, whereas many of the other demos are almost exclusively focused on just the vehicles themselves. So hopefully that gives us a nice breadth, and we'll be able to demonstrate a lot of different activities. I think that's a pretty good one. So a pretty good cover of all the activities. So thanks for your attention. And again, happy to provide that presentation and answer any questions.
Thank you very much, Jos. Thank you very much to everyone. I don't know if you have any comments or questions to the speakers or something you would like to like. I don't want you we have been 2 hours talking, so I guess you also you would like to rest and to go to the lunch break. But we are at your disposal. If you want, we can share our cards in case you want to prefer to talk later on, or any questions about the project we have presented so far, and any other aspect. We will be at your disposal now or later on, as I said. So if there's nothing else, thanks a lot. Thanks for the speakers and also for the rest of you that have been here. And keep in touch then. Thank you.